So some rational expressions do not fit our 1 over x minus p plus q form. So how do we write this expression here in this form? Well, what we have to do is actually put this into the division statement, and this expression here can be divided and we can end up with a quotient with a remainder over divisor. And this quotient then represents our horizontal shift, our vertical shift, and then this divisor is going to be the same here, and the remainder ends up being our vertical expansion. So we start with this expression, and then we end up with an expression that looks like this. And this expression then will be our transformation expression which we can use to graph this function. Now, this is again just a reminder, this is an alternative way to look at graphing this rational expression. So here we could have used a 0, we could use a vertical asymptote, and then we could find some other points to graph this. We're going to graph this using our transformation. And again, this is just an alternative method to graphing this function which we graphed before. So in graphing this function here, we have a vertical asymptote at -4. So this is how we would have graphed it before. We have a vertical asymptote at, not -4, but +4. I draw my vertical asymptote. I do my endpoint behavior. As x gets really, really big, the ratio of x's become 1. So I have my horizontal asymptote here. I can plug in my 0, x equals 0 at -3. There's my 0 there. And then I can plug in my 0, x is 0 to get a y-intercept, so it looks like somewhere around there. And then I can just sketch my graph in like that. Okay, so I have basically my rational function.